Don't look at me. Like, you know. Wait, let me start again. Hi, my name is Ava and I'm with Tutor Hub 101 and I'm here with my student Paige.
Hi.
Today we're going to go over the unit circle and I'm going to teach her how to memorize it super fast. Okay, you ready?
Yeah.
Okay, so we go over the angles first. And the degrees, we're going to start with the 30 degrees, which are all these guys. So these guys go up by 30s, starting right here, 30, and then the rest of them, 60, 90, blah, blah, blah. And then it's the 45s, which are every other one. So 45, then 90, 135, 180, blah, blah, blah. And then radians. Radians are the same as the pi over 30s. So, or the 30s. And then, so basically 1/2 of the circle is pi. So in this case, if we're doing pi over 6, we're cutting this pi into 6 parts. And we're just gonna start at the top here and go pi over 6, then 2 pi over 6, which we reduce, 3 pi over 6, 4 pi over 6, all the way around. There you go.
So the 30s are pi over 6s.
Yes.
Okay.
And then the pi over 4s are the ones that go up by 45s. Okay, so 45s, that means we're doing the whole pi and then dividing that into 4 parts. And so the first one's going to be pi over 4, 2 pi over 4, which is 90, and then all the way around. So you see that once everything reduces, it ends up reducing to be the same. Triangle review. So this one, we're just going over some 30, 60, 90 degree triangles and the ratios. So the ratios are A, 2A, and pi over 3. And in the unit circle, the 2A, or the hypotenuse, is always 1. So we go ahead and we set that equal to 1 and solve for A. So A is 1/2, and that's 1/2 right there, and the other one ends up being root 3 over 2 right there. Then the same thing, this is basically the triangle just turned around. And then the 45, 45, 90 triangle where we have the ratios B, B, and B root 2. And once again, B root 2 is equal to 1 because that's the hypotenuse. And we solve for B and we get root 2 over 2 after we rationalize the denominator. So those guys go right in there. And then this is all part of the unit circle, which basically just makes these triangles all the way around. And yeah, okay, so this part, 3 points. We are, so we're just looking at quadrant 1. We go ahead and name these 2 because we already know what those points are. Then here's the real trick right here. You're gonna put all the points, everything over 2. Then you start at the top and you're gonna go 1, 2, 3, and then the other side 1, 2, 3, and just put square roots over everything. And then we can also see how this fits into the all the triangles fit into here. Also, we just want to point out and say that right here, this is the like basically this is x, oops, x, and this is y. So sine is the y for each of these. Okay. Then we take this whole thing and we're just going to reflect it. So we reflect across that way and we fill all these in where the x's are negative. Reflect that way and one more, and then so that fills everything in. All right, your turn.
Okay.
Alright, so here you go, I'm gonna let you write on here. So start with the 30s. So this is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and then 330, and that would be 360. Awesome. And then the 45? Yeah, so it would be 45, 90, and then in the middle, right? So we can just add 15? Yes, you can. So 135. And then here, so add 15 to 225. And then add 15 here, give me 15. This is smart. Okay, awesome. Then let's go ahead and clear this one. Okay, let's do the radians. Okay, so 30s are pi over 6s. So pi over 6 is there. And then this would be 2 pi over 6. Or over, yeah. So that equals 1 pi over 3, right? Yeah. So pi over 3. And this would be 3 pi over 6. Which equals to pi over 2. And then that's 4 pi over 6. Okay, which is reduced and gives you 2 pi over 3. Yes. And then that's 5 pi over 6, but there's no reducing. Yeah, right. 5 pi over 6. And then that's 6 pi over 6. So that's just pi. And then 7 pi over 6 doesn't reduce. 8 pi over 6 does reduce. So it's 4 pi over 3. Awesome. And then 9 pi over 6 reduces. So it'd be 3 pi over 2. Awesome. And then that's 10 pi over 6. So it'd be 5 pi over 3. Yes. And then 11 pi over 6, which does not reduce. And then this is 12 pi over 6, which is 2 pi. Or, yeah, right? That's correct. And awesome. Then the 45. So then this is pi over 4. And then this would be 2 pi over 4, which is just pi over 2. And 3 pi over 4. Yes. And 4 pi over 4. And 5 pi over 4 there. Yes. So 5 pi over 4. And then 6 pi over 4. And then this would be 7 pi over 4. Perfect. Excellent. Let's do the points as well. So, here we go. Yeah. So, or just at least the one quadrant, or the first quadrant. So, you said 1, 2, 3, 1, 2, 3. So they're all over 2, so it'd be 1. That's a 2. So 1, 2, 3, 1, 2, 3. All over 2. Yes. And then the top number is squared. Squared? So it's like that. Yes.
There we go. Yeah.
Perfect. All right, cool. So that's looking good. Oops. Then, so let's try this problem, this example right here. Find the values of all 6 trig functions for theta equals 7 pi over 6. All right. So, what does this mean?
Is theta a degree or something?
Theta is, yeah, it's in radians. So like, let's say, here, I'm gonna pop this thing out. There it is.
That
So sine, if we're looking at this guy, right?
right.
Okay. And so right here, which means the coordinates are right there.
Right.
And so sine of this would be which one of these guys?
Sine. It's just like cosine comma sine, right?
Yes.
So sine would be negative 1/2.
Negative 1/2. That's perfect. Okay, here, do you want to do the others?
Yeah, so cosine would be negative root 3 over 2.
Mm-hmm.
So then, but tangent.
Tangent is sine over cosine?
Sine over cosine, so it'd be that over that.
Yes. So what's this going to be when you divide it? Remember, keep, change, flip. You keep the first one.
So
Change.
1 over root 3, that one?
Yeah, 1 over root 3. But then what does that become? Because 1 over root 3.
1 over root
You have to rationalize the
3. So
denominator.
1 over root 3.
Do you want to do it on the table?
So 1 over root 3 times root 3 over root 3. So it's root 3 over 3.
Awesome.
Ah.
Yes.
So
Here you go.
tangent is root 3 over 3. And then that
Cosecant. Have you guys done those?
No.
No. Okay. Cosecant is basically the inverse of this guy. So you just flip whatever this is. In this case, it's going to be 2 over 1, except negative 2.
Okay. So then secant would be cosine. So it would be 2 over root 3. Anybody need to rationalize that?
Yeah.
Okay, so 2 over root 3 2 root 3 over 3. Perfect. So let's get that. 2 root 3 over 3. And cotangent would be 3 over root 3. But I have to rationalize that first.
Yeah. Oh, this one.
Yeah.
Yeah, but what was it before we rationalized it? Because you wrote it down here. So 1 over root 3. So
Oh, so it's just root 3.
yeah, it's just
Okay.
root 3.
Here you go.
Okay, cool. Very nicely done. And how about these guys? State the quadrant that these thingies are in.
Okay. So I'm gonna draw a thing.
Go for it.
So if sine, you said cosine on the sine. So sine is less than 0.
Yeah.
Means it's negative,
Yes.
right? So then it would have to be sine is y value, so it would have to be somewhere in
In
these
this.
two.
Awesome.
And then if cosine is less than 0, that means though the x and y are both negative.
Yes.
So then it'd have to be here because this is the only place.
Yes.
So quadrant 3.
Quadrant 3 is correct. Next one.
So sine is greater than 0, so it's above this.
Yes.
And then cosine is also greater than 0. So that means it has to be on this side. So then it would be right here in quadrant 1.
1 is the answer. And next one.
So sine is greater than 0, so it's up here.
Mm-hmm.
And tangent is greater than 0.
Yeah. Tangent is greater than 0.
And tangent is sine over cosine.
Yeah.
So it would have to be positive, which means if the sine is positive, cosine has to be positive. So would it be in 1?
This one, yes, it would be actually. Where else is tangent positive?
Oh, heat 2.
Because remember, this is negative cosine, and then the sine is positive here, so.
So negative, negative. So it would be
Yes.
there.
Quadrant 3, exactly. All right, how about this one?
So secant.
Yes.
You said secant was the opposite of sine or
No,
cosine?
it's cosine.
Cosine.
Yeah, I always remember that this is S, so it relates to the C, and then this one is, oh, that's cotangent, but that's a different thing. But yeah,
Okay.
that's how I remember. Okay.
So secant is greater than 0,
So
which means that cosine is greater than. Would it be the same?
yeah, because it's just flipped around, right?
Okay.
The sign is going to be
Right.
the same. Yeah.
So secant is greater than, so cosine is greater than 0, which means it has to be on this side.
Okay.
And then cotangent, so tangent is greater than 0.
Okay.
It's positive, so it has to be in quadrant 1.
Okay. So yes, that is correct. Cosine is positive and tangent is positive as well. Yes. Awesome. I'll just put that in there. Okay. Give at least 2 solutions for theta in radians. What do you think? What's this thing?
So sine equals 1/2.
What do you think they're asking?
2 solutions. Okay. I honestly have no idea.
Okay, let's look at this thingy, right? They're telling us that sine is equal to 1/2. So this is the variable, theta is the variable in this case, right?
Right.
Yeah, so what theta stands for an angle. What angle basically is sine equal to 1/2? That's what they're asking.
Oh, okay.
Yeah.
But only positive, so the negatives don't count right now.
No, it doesn't say that. It just says that they want 2 solutions. Oh, you mean positive 1/2?
Right.
Yeah, only
Okay.
positive 1/2.
So would it be like 60? Would 60 be 1? No, cosine on the sine. So it'd be 30.
It will be
Right.
30, yes. So what do we say for that? Pi over 6? Because the thing is, if they give you this theta, that means they want the answer in radians.
Okay.
Yeah.
So, yeah, so 30, and then also 1/2 is, would be 150, which is 5 pi over 6.
Awesome. Why am I doing the writing here?
Oh, sorry.
All right, go for
So
it.
tangent is 1,
Mm-hmm.
but that's not a coordinate. So would I have to divide it first?
Yeah, you gotta think about where it's gonna be 1.
So it's positive, I know that. So it has to be one of these two.
Yes, very nice.
And so then, would it have to be where the cosine and the sine are the same?
Yeah, exactly.
So it would be cosine and sine. So would it be like, oh wait.
Where is sine and cosine the same?
Oh wait, 45?
Yes, exactly.
So 45, so it's pi over 4.
Pi over 4, and there's one more.
And then, 225, so 5 pi over 4.
Yes. Aw, you're so smart, Paige. All right, very nicely done. And I think this is the end. Okay. So, we can't even see ourselves anymore because the computer fell asleep. Okay, well, thank you for doing this for me. And actually, I have something for you.
Oh, okay.
And especially because I didn't hear any limiting beliefs or anything, I'm very proud of you. Check it out.
Oh, that's so cute.
You like it?
That is so cute.
Aw, I'm glad you like
Oh,
it.
that's so cute. Thank you.
Sure.
Oh, I love that. That's so. My mom's gonna love it too.
Really?
She goes, I love those things. I want you to have one.
Oh,
Thank you.
sure.
I appreciate you greatly.
Oh, well, all right. Stay tuned to Tutor Hub 101 for more videos.
Oh yeah.
All right, bye.